So guys, welcome back to yet another episode of DSA Python series, and today we will be talking about uh, rotating a 2D matrix. Okay, so rotate a matrix by 90 degree. Okay, so how you can rotate a matrix by 90 degree? What is the first thing that comes to your mind? Let us uh, let us do some brainstorming. Okay. So let's say this is my array, that is 2D matrix. Okay, and these are all my elements: 1, 2, 3, 4, 5, 6, 7, and 9, 10. So when you rotate this array by 90 degree, what is happening is, you can see here, this 1 is coming here, right? Just imagine you have rotated this, you have written this in piece of paper. Actually, you can write this in piece of paper, and you can just rotate it like this. So what you will be getting is 1 is coming here. Okay, 1 is coming here. This 2 is coming here. This 3 is coming here. And this 4, this is 3, and this 4 is coming here. And so what is happening is, this row, first row, first row of this 2D matrix is becoming the last column. All right. The first row is becoming the last column, right? First row is becoming the last column. What about second row? Let us think about second row also. This 5 is coming here, right? This 6 is coming here. Okay. 7 and 8 likewise coming here. So the second row of this matrix is becoming the second last row, column, second last column of this rotated matrix. Okay, this is how it is happening, right? So what do we have to do? We have to think some formula, or you can say some strategy, where we can actually rotate this matrix by 90 degree. So if we talk about the lead code question, let us discuss that question also. So set matrix 0, rotate matrix by 90 degree. Okay, so this one. So this is the lead code question number 28. Okay, and rotate image. Okay, so basically this is an image. They're considering it as image, and you have to rotate it like this. So 1, 2, 3 becomes this 1, 2, 3. 4, 5, 6 becomes the second last column, and the third row becomes the first column, right? Third row becomes the first column. Okay, this is again, so let us read the question first. So you are given a n cross You are given an n cross n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So basically we just have to rotate the image clockwise. uh, you have to rotate the image in place, right? So in place means that whatever this 2D matrix is given, we have to change the elements in this array itself. Okay, this is the idea in that array itself, right? Which means you have to modify the input 2D matrix directly. So do not allocate another 2D matrix and do the rotation. So guys, as of now, what I think is, uh, as a brute force approach, we can go with taking an extra 2D matrix. Okay, just for understanding purpose. So that will be our brute force solution. Okay, that is the thing which is first comes to my mind. Okay, so to the question observation, whatever is the instructions given in the question, that we will also be doing. But the first thing which is coming to my mind here is, let us assume one 2D matrix and we will just put the elements like this. Okay, so that becomes our brute force approach, very basic naive approach. Okay, so let us start with that solution in mind. Okay, so this is the rotate. Okay, so this is the matrix. Now I want this matrix, right? I want this matrix, and let me just, okay. So let us draw the I and jth rows, okay, one by one for this matrix. Okay, so 0, 1, 2, 3. These are the rows number, and 0. Okay, let me just take another color. So this is 0, 1, 2, 3, and this is 0, or else I take yellow. 0, 1, 2, 3, right? Similarly here 0, 1, 2, 3, and here I'll just stroke 0, 1, 2, 3, right? Now see, let's talk about this one. Okay, its position in initial matrix is 0 comma 0, right? So what is my ij? It will be 0. This is I, 0 comma 0, right? This is my matrix, and when it gets rotated, its position comes here. Okay, so its position is 0, 3. Okay, so its position comes as 0 to 3. Why we are writing this here? Because we want to analyze what is the relationship between these two. Like how can we deduce some relationship so that it becomes a generalized approach for rotating that array, right? So your array can be of any number of elements. It can be n cross m, it can be m cross m. Okay, it can be 10 cross 10, it can be 1000 cross 1000, it can be 1000 cross 900. So you need to have, you cannot, make each and every element, shift to that position. Okay, that is not possible manually. So you have to come with a solution. Okay, so that uh, you can in general, assume everything, and you can have some formula so that you can directly have a approach, right? Now talking about this, so it is 0 comma 1. Okay, so let us write it. So it is 0 comma 1. It is getting changed to, where is this 2? 2 is here. So it is getting changed to 1 comma 3. Okay. So it is 1 comma 3, right? 3 becomes 0 comma 2. It is 0 2. It becomes 3 is here, 2 comma 3, right? Ij. And what is fourth? It is 0 comma 3. So it becomes, fourth one is 3 comma 3. Now just look at what is happening here. So you can see that, let me just take another color. So is there any relationship between this and this? Because these are rows. Okay, so this is 0, this is 0. Then again 0, this is 1. Then again 0, this is 2. 0, 3. So we are not able to find any relationship. Okay, all right. What about relationship with this and this? So when it is 0, it is 0. When it is 1, it is 1. When it is 2, it is 2. When it is 3, it is also 3. Okay. So we can see that j becomes my I. So my j becomes I, right? This is my relationship as of now. Now let us try to gather some information for this. Okay. So all my 0, and so this is my uh, row. All my row becomes this. So you can see that all 0 has become 3. Okay. So now can you try to find out any relationship between this row and this row? Can you think of any formula? N minus 1 minus I. Okay. So can you think about that, the formula? So we will try to match both these permutation combination so that we can get this formula, and this formula is valid on which combination, that also we will check. So if I is 0, let's say my I is 0, so n minus 1 will be, so here the value of n is 4, right? Because length of our array is 4, right? 0 1 2 3. So length, if you consider, that is 4. So 4 minus 1 becomes 3. Okay. So whenever this is 0, we are getting 3. Okay. So this can be the thing. What about this? Is this formula valid for this column and this column? Is it valid? Just check. N minus 1 minus I. Okay. So what is n? N is my 4, right? Here my n is 4 and I is 0. So when I is 0, 4 minus 1 is equal to 3. Okay, I'm getting this 3. What about I is equal to 1? 4 minus 1 is equal to 2. Am I getting this? No, I'm not getting. 4 minus 1 minus 1. Okay, so I'm not getting. So what I'm getting is, whatever is my this 0, this formula, it is valid for this, right? This is what I'm getting, right? So can you think of uh, now can we write some code? let us try writing some code, okay, based on this explanation, right? So I'll just now, for having a matrix, like we have to copy all the elements, okay. So for having the matrix, we just need a new matrix, right? So what we discussed is, we actually want, as of now, we will be wanting a new matrix, okay. So just consider this matrix as result, right? So I'll just consider this matrix as result, and what I want is, I want similar matrix with same parameter, but all the values I want is 0, okay. So how I can write that? So there is a standard formula for writing a 2D matrix which consists of all zeros elements, okay. Just we have to write, this is my initial matrix and this is the second matrix, okay. So 0 for underscore in range n, right? I have to define my n also. N is equal to len of nums, okay, or matrix here, right? So what this will create? This will actually create like this: 0, comma 0, comma, okay, like this, not comma. This will be the matrix created with the single command, okay. Now I want this matrix to have the second dimension also, okay. So for that, I just have to write for underscore in range n, that's it, okay. And I'll close the square bracket, for underscore in range n, okay. So I'll just write here for underscore in range, okay. So this will create our empty matrix, okay. This becomes my empty matrix, okay. I think this should work, okay. Now what I'll do is, i'll I'll do the iteration of the uh, this thing, okay. So what I'll write, I'll just write for I in range 0 to n, and I'll be writing a nested for loop, right? Okay. So that will be for j in range 0 to n. Now what I'll do is, I'll I'll consider that j, okay, whatever is my j, I want to copy I to j, okay, because my row was equal to the column of that matrix, okay. My row, okay, so my row was 0 0. Okay, and that row I have changed to column. Okay, I need to change to column. So using n minus 1 minus I, I'm getting all the row number through that, through initial row number. Okay, and my j, if I put that formula also, n minus 1 minus I. Okay, so n minus 1 minus I. See, in range, I'll just try to write it. Let's see if in case result. What I want is, I want matrix element to get copied to result. So result of, say, n minus 1 minus I. Okay. Is equal to matrix of I and j. Is it, will it give result? Okay, the code is correct, but we are getting wrong answer. Uh, what we are getting is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are not able to rotate this. Why? Because this is only the thing. Okay. If this is correct, then your matrix gets rotated. If something is wrong, then you have to just check whether what is wrong. Okay. So basically what I'm doing is, whatever is my result j, that is equal to matrix ka I. Okay. So whatever matrix ka I, so matrix ka I is 0. All this is becoming the j. Okay, I put 0 here. Let us try revisiting the screen. So n minus result of j. So matrix of I is the result of j. Matrix of I. The matrix of I is my result of I. No, matrix of I is matrix of I is the result of this formula result of j. Matrix of I is 0 result of j. Okay. And matrix of j is equal to matrix of result of I. Matrix of j is equal to result of I. Matrix of j is equal to result of I. Okay, this is correct. Answer should come. What is wrong in that? Matrix of j is result of I. So whatever is my j, I'll make result j and the another bracket with this formula. Correct. This is correct. I can't find any mistake in this. So whatever is the column of matrix, it has become the row of result. So column of matrix is the row of result. column of matrix. Okay, so I will not return this result. I'll just say matrix j is equal to result j minus 1 minus I. So question says you have to modify the input. Do not allocate another 2D matrix. So basically we have to do in place. So this is making my empty matrix, empty 2D matrix. Empty matrix. I and we are equal. Okay. And cross n.
उनके तुम्हारी लाइफ से
If we go by another way, then let us try considering more optimal solution. Uh, let's say this is my array 1, 2, 3, 4, or 2D matrix. You can say 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is my matrix, and what I want to do is I want to reverse, I want to rotate it. So after rotation, my matrix becomes like this. So if I want to do it in place, if I want to do it in place, the rotation, then what another method we can use? What another method we can use so that there is a probability of rotating this matrix by 90 degree. So what comes to my mind is, let's say this is my diagonal matrix. If I try to find the transpose of matrix, guys, you must have studied the transpose of matrix in your 11th standard maths, right? If you have not studied, then please go revisit the concept. What happens in transpose is, let's say this is my 0 1 2 3, and this is my 0 1 2 3. So here, if I want to create a transpose, then what will be my transpose matrix? It will be like this. So basically this row becomes this column becomes the row. Okay, so it becomes like this: 1 5 9 13, then this 2 6 10 14, then 3 7 11 15, and then 4 8 12 16. Okay, so this is my transpose matrix, and what is happening is, you can see this 2 and 5 have interchanged. Okay, so this 2 has come here and 5 has come here. So I'll just draw the diagonal. Now you see this 3 and this 9. Okay, so this 3 and 9 have also interchanged. So what is happening is 0 1 2 3 0 1 2 3. Okay, so if I try to find my ij, if I try to write my ij, uh, all my I all my ij where I is equal to j are same. Can you see it? My position of 1 is same. Position of 6 is at 2 1 comma 1, indexing 1 comma 1. Position of 11 is 2 comma 2. Okay, and position of 16 is 3 comma 3. That is not going to change because this is a diagonal of the matrix. Okay, now so now how do we write I and j of other elements? So my 0 comma 1 has become my 1 comma 0 in the new matrix. So my 0 1 has changed to 1 0. Okay, let us talk about 5. My 1 comma 0 has changed to 0 comma 1. Okay, so 1 0 changed to 0 1, right? Then my 2 comma 0. So let us talk first about this column only. So 0 comma 0, 0 comma 1. Okay, 0 comma 1, and then 0 comma 2. Okay, so 0 comma 2 is changed to 2 comma 0. Okay, just we will go sequentially. Then 0 comma 3 becomes 3 comma 0. Yes, 0 comma 3 is my 13, and here 13 is at position 3 comma 0, right? Now let us start with first row. So in first row, 1 comma 0, 1 comma 0 becomes my 0 1. Yes, then 1 comma 2 becomes 2 comma 1. So I'm ignoring the diagonal element. Okay, then my 1 comma 3, 1 comma 3 will be 1 comma 3 will be this element. So 1 comma 3 will become 3 comma 1. Okay, and okay, that's all. Now let us start with this 2, row number 2, sorry. So 2 comma 0 becomes 0 comma 2, then 2 comma 1 becomes 1 comma 2, and 2 comma 3 becomes 3 comma 2. So how do we write the code for the transpose of matrix? Basically what is happening is, for I in range 0 to n, okay, and for j in range, okay, so what is the value of I starts from 0 and it goes up to 2, right? What about 3, third row? If I talk with that, then it will be a repetition. Okay, so my I will start from for I in range 0 to 0 to 3, because it is coming up to 2, so I have to consider 3. This will be excluded in for loop, right? So 3 is basically n minus 1, because the value of n is 4. So 4 minus 1 is 3. Yes. And what is the value of j going? So j is coming from, if I value of I is 0, j is starting from 1. It means that for j in range I plus 1 to j is coming up to 3. It means that up to n we are getting the value of j. And now we have to swap it, right? So how to swap in how do we swap in Python? Simply matrix of I j comma matrix, this is I, and I is equal to matrix of j I comma matrix of I and j. So this is how we uh, create the transpose of matrix. Okay, this is the code for creating transpose of matrix. But why we are creating the transpose? Just look at this. Once we have created this transpose, just rub it. So you can see here, when I have created this transpose, just look at this number and this. I'll just create a copy also. Look at this, these two. So this is the reverse. Oh, sorry, this is the this is the number which we actually wanted. This is the result of the previous uh, attempt. Okay, so this we actually wanted. So this is the transpose. You can see this is the transpose which we have created. And if you visualize properly, this transpose is, if we reverse this transpose, if we reverse this list, okay, just think about this. If we reverse this list, then we will get this, right? It's 13951, 13951, right? So after this code, what do we have to do? We just have to reverse the matrix, right? We just have to reverse the matrix. And how we can reverse the matrix? Let us see everything in code, right? In lead code. I'll just put the lead code. Okay, so this is our coding platform, and I'll just say I'll just write all the code which we have created. So it will be for I in range 0 to n. Okay, so I want this n minus 1, right? So whatever we discussed there, for j in range, it is I plus 1, I plus 1 up to n. Yes. Now what I'm doing is I'll have to uh, I'll have to swap. I have to swap all the values, right? How do I swap? I'll just write matrix ij comma matrix ji is equal to matrix ji comma matrix ij. That is how you can rotate. Sorry, you can swap. So matrix ij, and just copy this comma comma. So this will be matrix ji, and this will be matrix ji, and this will be ij. And after that, once this matrix is created, then I will just say I have to reverse this complete this thing, right? So I will come on this loop first. I will say matrix of I. I want I to be reversed, right? Dot reverse. That's it. I think this should work. Okay, this is not getting reversed. Why? Should I go out of loop? No. Otherwise, how it will iterate I? Okay, my I has to be up to 3, right? Yeah, because third one also we are taking, no? Yeah. So guys, this is the most appropriate solution. Okay. This logic is also correct, but I think there is something which I'm missing. But still, we have found another great solution. We have actually done the transpose, and then we have done the reverse. So whenever you want to rotate any image, okay, so whenever you want to rotate any image of 2D matrix, then you should first transpose it and then rotate all the rows of transpose matrix. So whatever matrix you have transposed, that matrix you have to reverse it. You will get 90-degree rotated matrix, right? You can get that. Now let's discuss the time complexity. What is the time complexity? Time complexity will be, since we are running two loops, it will be order of n square. Yes, it will be O of n square. What is the space complexity? I have not taken any space, so it will be order of 1. That is constant space. Constant space, right? So this is how you can solve it. I'll just submit it once. Oh, sorry. All right, the our case is submitted and all 21 test cases have been passed, and there are more challenges. You can do it yourself, and if you want to discuss the similar questions, whatever we are doing, just comment, and uh, I'll get you the very optimized and very nice explanation video for you guys. Okay, so that we can understand what 2D matrix is. However, some companies have been asking this question on 2D matrix, and it's pertinent to note that you have to prepare how you can do the solution with 2D matrix. Okay, how you can arrive at the solution, how to uh, prepare your this thing. Logic building is also very necessary in the case of 2D matrix. Okay, so this is that's all guys for today, and I think you must have understood how 2D matrix can be solved. Guys, please try to solve this way also. Okay, taking another uh, different matrix result. This is also solvable. Okay, but simply this solution is perfect solution, right? This is very good solution. Okay, so see you guys tomorrow. So today was day 19 of live DSA Python series, and tomorrow I'll be coming with another question that will be based on spiral matrix. Okay, how can we print the matrix in spiral manner? Okay, that we will be doing. Okay, so till then, bye bye, good night, and take care.